Welcome to This Explainer. Today we're diving into a biological mystery that is honestly mind-blowing. We're going to explore how very specific wavelengths of light interact with your skin to release a powerful, full-body healing molecule. You know, we usually think of light just in terms of vision or, well, getting a nasty sunburn. But today, we are looking at light as a profound biological trigger.
But before we get into the nitty-gritty mechanisms, we really have to ask a profound question. Think about it for a second. Can the everyday light hitting your skin actually act like a literal key to unlock profound health benefits trapped right inside your body? I know, it sounds a bit like science fiction, but the biochemistry happening just beneath the surface of your skin tells a very real and very scientifically grounded story.
All right, let's map out our journey across the electromagnetic spectrum. We'll start with the skin's secret reservoir, tackle the ultraviolet dilemma, look at blue light's mixed bag, discover the red and infrared solutions, and wrap up with systemic healing and beyond. Let's jump in.
Section 1. The Skin's Secret Reservoir. To really get this, we first need to figure out what kind of precious cargo our skin is actually hoarding.
That cargo is nitric oxide, or NO for short. It's an absolute powerhouse, a ubiquitous jack-of-all-trades molecule naturally made in our bodies by enzymes known as NOS. And once it's created, NO does some incredible things. It relaxes blood vessels, speeds up healing, and sends absolutely crucial signals throughout the body. But there's a pretty big catch. Because it's a free radical gas, nitric oxide has a lifespan of just a few seconds. So to survive, our body literally has to stash it away efficiently in more stable forms. And that's exactly where your skin comes in. Imagine your skin as a giant bank vault for nitric oxide. It stores NO derivatives like nitrite and RSNOs at remarkably high concentrations. To put that into perspective, in healthy people, skin nitrite is about 25 times higher than what's floating around in your blood plasma. And get this, skin RSNOs are up to 360 times higher than what's in your blood. The skin is quite literally a massive reservoir of potential healing energy wrapped right around you.
So, if the skin is a vault, how do we crack it? Well, the electromagnetic spectrum is basically our treasure map here. It shows us which specific wavelengths of light act as the best vault crackers. The spectrum ranges from the really harsh, high-energy ionizing ultraviolet rays all the way on the left, moving through the visible light we can see, and extending all the way to the deeper penetrating, much safer infrared wavelengths on the right.
Moving to Section 2, the ultraviolet dilemma. Let's talk about the high-energy hazards waiting for us on the far left of our map. For years, science has recognized that UVA light is basically the brute force vault cracker. It uses a process called photolysis. Now, photolysis is a non-enzymatic reaction, meaning it completely ignores those helpful NOS enzymes we mentioned earlier. Instead, the intense radiation energy of UVA light just directly smashes the strong chemical bonds of the NO derivatives, especially nitrite, and violently frees the active nitric oxide radicals into the surrounding skin tissue.
Here's the catch. And it's a huge one. Yes, that UVA-induced brute force successfully mobilizes those stores and brilliantly lowers your blood pressure. But it traps us in a serious dilemma. Those exact same ionizing rays are notorious for causing severe DNA damage. They accelerate premature photoaging, and they significantly spike your risk of both melanoma and non-melanoma skin cancers. You get the medicine, but man, the side effects are just incredibly steep.
Which brings us to Section 3, Blue Light's Mixed Bag. We're looking for something safer, but as we'll see, it's not quite perfect. Trying to escape that danger zone, we shift slightly to the right into the visible realm with blue light, which makes up about half the solar rays hitting the Earth. Because it carries less energy than UV, it actually can't break those tough nitrite bonds. Instead, it goes for easier targets, the RSNOs. Compounds like SNAC require way less energy to break down, and blue light has just enough juice to snap those specific bonds and release their NO.
But you know, it is still very much a mixed bag. Sure, it manages to avoid the absolute worst, ionizing hazards of UV, and it successfully lowers blood pressure by generating that local NO. But if you're exposed to it for too long, even at intensities that just mimic regular sunlight, it generates these bursts of reactive oxygen species, basically free radicals. And if left unchecked, that leads to cellular death, damaged skin barriers, and persistent dark spots or hyperpigmentation. It's safer, for sure, but definitely not perfect.
And that brings us to Section 4, Red and Infrared Solutions. This is the exciting climax of our journey, featuring the deeper, safer heroes of the spectrum.
Deep inside our cells, in the mitochondria, we have this crucial enzyme called cytochrome C oxidase, and it has these very distinct absorption peaks right at 660 nanometers, which is red light, and 850 nanometers, which is near infrared light. By utilizing these specific longer wavelengths, we can completely bypass the nasty ionizing radiation and hyperpigmentation risks while penetrating deeply and safely right into the skin.
The whole game changes beautifully right here. Instead of that chaotic, brute force photolysis used by UV and blue rays to aggressively smash chemical bonds, red and near-infrared light use pure finesse. They unlock the NO vault enzymatically. When these wavelengths absorb into the water and cellular components in your dermis, they generate a very mild, inside-out heating. This gentle temperature shift actually stabilizes heat shock proteins, which in turn supercharge the activity of the NOS enzymes themselves. It's a much safer, totally biologically harmonious, and controlled release of nitric oxide.
Section 5. Systemic healing and beyond. Now that we've found a safe way to access the vault, what does this actually do for our overall health? Now remember earlier when we said NO dissipates in just seconds, you might be wondering how on earth does a reaction in your skin end up helping the rest of your body? The secret is transportation. Once the NO is released locally in your skin tissues, it gets snatched up almost instantly by a protein in your blood called albumin. And since albumin is everywhere in your blood plasma, it acts as a circulatory transport vehicle. It literally turns local light exposure on your skin into a massive, full-body healing cascade. The real-world results from this light-induced transport? They are genuinely staggering. By safely tapping into the skin reservoir, clinical studies are seeing normalized vascular tone, significant drops in blood pressure, and way less systemic inflammation. On a local level, it protects against cell injury and speeds up wound healing. It even supports your innate immune system and cuts down on muscle fatigue to boost exercise performance. It is literally light acting as medicine. As we wrap up this explainer, I really want you to think about this. We have become so accustomed to just hiding from the light to protect our skin, but the science clearly shows that our skin is fundamentally built to use non-ionizing light as a powerful metabolic trigger. So ask yourself, how can you thoughtfully harness these safer red and infrared wavelengths to turn your everyday light exposure into powerful systemic medicine? Thank you so much for exploring this incredible biophysics journey with me today. Keep learning, keep questioning, and I'll see you in the next explainer.